In this part of the demonstration, we're going to use the Apache Hive Metastore, and we're going to use PrestoDB, similar to how we used the AWS Glue Data Catalog and Amazon Athena previously. We're going to be cataloging the raw artist and artwork data, and we're going to be refining that data. We're going to create some tables in Apache Hive, very similar to what we did with the AWS Glue Data Catalog. In order to create those tables, instead of using Amazon Athena, we're going to use PrestoDB through Superset. Apache Superset is the interface that we'll be using. Apache Superset interface, the UI in some ways is very similar to Amazon Athena, but Superset has many more capabilities than Amazon Athena, things like charting and graphing, creating dashboards, different things that you would need to use a number of different tools on AWS platform for. We can do all of that through Superset, including actually querying AWS Glue Data Catalog, so we're not limited to Apache Hive for our queries. In order to save some time, I've already set up some databases. So in order to use Superset, you need to tell it where your data sources are, which it refers to as databases, but those can be any data source. So I have 3 databases or data sources. One of those is my PostgreSQL RDS database, which we talked about a little earlier. If you recall, I had originally exported the data from Kaggle and then imported that into a PostgreSQL database running on AWS. I had created a MoMA database with a public schema and then imported the 2 tables into that database. I made a connection in Superset to that just to show you that you can have many different backends. They're not necessarily just Apache Hive. In this case, I have the RDS database. I also have our AWS Glue database. So you recall in the last part of the demonstration, we created the AWS Glue Data Catalog named MoMA. And within that MoMA, AWS Glue Data Catalog, we had 4 tables, which represented data in S3. 2 tables for the raw data, 2 tables for the refined partition Parquet data. How did I associate the AWS Glue Data Catalog with PrestoDB? That was something, if you recall, I mentioned earlier I had 2 data sources. One of those data sources is the AWS Glue Data Catalog, which we were just working in. I created that data source. I gave it the proper information, security information, and URL information. And then I associated that data source with our demo cluster demo. When I'm in Superset, this instance of Superset is part of that cluster. And since I've associated that data source with this cluster, I'm able to create a database, or again, I'll call it a data source in Superset, which is the AWS Glue Data Catalog associated with PrestoDB. I've also created a third and final database or data source, which represents the Apache Hive Metastore, which came as part of the cluster. So if you recall, the other option was you can create a Apache Hive Metastore as part of the cluster, which we optioned to do, called Ahana_Hive. And this is the Metastore that we're going to catalog the data that's in our S3 bucket in. Instead of using AWS Glue Data Catalog, we're going to use this Apache Hive Metastore. So that's our third database or data source. And this is the one that we're going to be working with. So in order to work with that, similar to how we worked with Amazon Athena, I'm going to use the SQL query interface in Superset. And in some ways, this looks very similar to Amazon Athena. You can see here that I've chose my PrestoDB Ahana Hive database. That represents this data source, which is associated with my cluster. So when I write queries, those queries are going to be executed against this Apache Hive Metastore. There are 3 schemas that are associated with this. We're going to use the default schema, and there are currently no tables, so we're going to be creating tables as part of this. Currently, there are no tables. If I flip back to PyCharm, I've already written the queries that we're going to need in order to create these tables. So let me grab the first query. This will look very similar to the queries, the create table as queries that we ran in Amazon Athena. In this case, instead of creating an external table, we're going to be creating a table directly in Apache Hive. A couple differences. You'll notice that all of the column types are varchar. That is a limitation of CSV. If we're creating a table in Apache Hive, which references underlying data in Amazon S3 in the CSV format, those column types have to be varchar. You notice the separator is the same pipe. Our quote character is a double quotes, and the external location is the same location that we cataloged using AWS Glue Catalog and Athena, which was the artwork raw and the artist raw, so these pipe delimited raw files. And we're simply going to catalog those. So instead of cataloging those in AWS Glue Data Catalog, we're going to catalog those with Apache Hive. So let's go ahead and run this first query. Hopefully that will succeed, and it did. So it took 1.54 seconds to succeed. And if we look at tables now, hopefully we'll see that a new table has been created, which it has. So instead of having artist raw Athena, we now have a corresponding table in Apache Hive Metastore, our other Metastore, which is artist raw PrestoDB. We will do the same as we did before. I'm only going to do the artist for the sake of brevity here. So I'll do the same thing. I'm going to create a refined table. And let me grab this query, then I'll explain what we're going to do. This is going to look very similar. So again, we now have a table which represents the raw artist data. I'm now going to create a table which makes a copy of that raw data, performs some ETL on it, cleans it up, and then we're going to write that back to S3 into a new directory, and that's going to be partitioned again by nationality. So very similar to what we did in Amazon Athena, we're going to do that with Superset using the PrestoDB analytics engine. The table is going to be in Apache Hive instead of instead of AWS Glue Data Catalog. Now you can remember with CSV, the CSV file, since we defined every column as varchar, we want to make sure that we cast these correctly when we write them to Parquet. So I'm going to cast the artist ID from varchar to integer. In the case where the gender field is blank, we want to replace that with a null value. In the case where the birth year or death date are blank fields or varchar of 0 length, again, we want to replace those with null, and we can do that using the try-cast method in PrestoDB. And you'll recall with nationality, we clean that up. So if we had any empty fields, any null fields, any variations of nationality unknown, we wanted to make those all nationality unknown with the capital N and the capital U. Lastly, just to make sure that that artist field isn't there, it's already gone, but just as a check, we'll use that again. It's probably unnecessary. We also want to make sure that none of the names of the artists are blank. Now, again, we already did that previously, but we'll just make sure again that we eliminate any artist that their name is blank. So we only want records written to Parquet where we know the nationality, or we identify the nationality as unknown, and we know the name of the artist. Is not going to help us if we don't know the artist's name. So let's go ahead and run that. And again, this will take a little longer. This is actually writing Parquet. We're writing this to a new location, so we're not overwriting the Parquet that we created with Amazon Athena. This should create a new set of Parquet files. One of the limitations you recall we ran into with Amazon Athena was the 100 partition limit. With PrestoDB using Apache Hive, we don't have that limitation, so I'm not limiting it to 7,500 records and then coming back and inserting the additional records later on. We can read all 15,000 records and create, I believe there was 123 nationality partitions. We can do that all at once. So you can see here that that succeeded. We have a little over 15,000 rows. If I go back to S3, go back to our S3 bucket, and let me refresh that. And you can see here that now we have a directory called artist refined PrestoDB, as opposed to artist refined Athena, which we created earlier. If we go into here, you can see again we have 123 nationalities. You recall that we had 123 when we did a similar query in Amazon Athena with AWS Glue. You can see that we have all of our nationalities, and again you can see that there's our change. So nationality unknown, any nationalities which the fields were empty, null, or a variation of this are now all nicely placed under this. And then in each side, each one of these partitions, the nationality partitions, we have one or more Parquet files which represents the artists or fall under that nationality. So again, for nationality unknown, if we want to take a quick look, we can use the S3 query by query with S3 select feature. We know that this is Apache Parquet. We know we want to display it as JSON, and we'll just do a quick select all, limit 5. And you can see, in fact, that we have artists. So for artists that we don't know the gender, we don't know the birth date or the death date, we're only going to have the ID and the name. For ones that we know the gender, we'll have the gender. And then for other ones, there's no examples here where we know the birth date and the death date and or the death date. Those will also be displayed. Actually, let me just grab a few more here and make sure that. So yes, in fact, here we have an artist where we know the name, the gender. In fact, they are deceased, so we have the birth date and the death date. So this is a complete record. So you can see how those files are stored. This is just representing a visual representation in JSON of how the files are stored in Parquet. So now if we go back to Superset, we can see that if I refresh our table count, we in fact have two tables, artist raw PrestoDB and artist refined PrestoDB, and those correspond to the similar tables we created again with Amazon Athena and AWS Glue data catalog. But in this example, we've used superset, and what we've actually done is use the PrestoDB engine, and we have created these tables in Apache Hive, the Apache Hive version that came pre-installed with our cluster when we created it using Ahana Cloud for Presto. Now that we have our artist table, again, for brevity, I did not go ahead and create the artwork tables, but it would be very similar to the process that we went through to create these two tables and the artwork tables that we created using Amazon Athena. Quickly, just to run a query and show you the results. So again, we looked at S3. We were able to see all of the partitioned Parquet files that we created. These files were created in S3 using Presto. The metadata information, the schema, is stored in Apache Hive, and we can write a query against that Apache Hive data source and return results from the underlying S3 data, in this case, the Parquet data. So if you recall the queries that we ran last time, I'm going to take the exact same query that we ran last time. Let me drop that in. Now, you can recall last time we used Athena, so let me change this to match the name of the table. You can see we even get autocomplete there. This is going to run a similar query. Again, we're going to run this against the artist refined. And you can see that we got results back. Let me just run that again. There we go. So we got the top 25 artists in alphabetical order, where gender is not null, nationality is American. We were looking at the name, the nationality, the gender, the year of their birth, the year of their death. If we do in fact have both of those fields, then we've calculated the length of their life in years. And you can see that again works. So we have 71, 84. And we have the first 25 records. We could easily view all of those. Query was ran against Apache Hive using PrestoDB analytics engine. In this case, since we use the nationality of American, Presto was able to push that query down to the S3 location, and we were able to only query the Parquet file, in this case a single Parquet file. We were able to only query the artists which were within this partition of American, so we didn't have to search all 15,000 records for any artist whose nationality was American. We simply only searched this directory, so hypothetically that query should be much faster. So we've run that query against our PrestoDB Ahana Hive data source, which represents the PrestoDB engine running against Apache Hive. We can run the same query against the corresponding table in AWS Glue without leaving superset and using PrestoDB. So I'm going to switch my database or my data source to AWS Glue. So this database, this data source, again represents the data source that we created and applied to or associated with our cluster in the Ahana SaaS console. And I have provided that information again to superset to be able to create this database or data source. You can see here that I've selected AWS Glue. We see that there's three schemas. We should recall that the name of our AWS Glue data catalog was MoMA. So this is actually, in this case with Glue, is listing our data catalogs. So we want to pick MoMA. And hopefully we'll see four tables appear here, which we do. And these are the four tables that you recall we created using Amazon Athena originally. So we have the artist raw and refined and the artwork raw and refined. So I'm going to take the same query that we ran against Apache Hive, and I'm just going to change the table name to reflect the table which exists in the AWS Glue data catalog MoMA. And we're going to run that against the artist refined Athena table. And you recall that table represents data which has been written to S3. It is partitioned by nationality. It is written in a compressed Parquet format. So we're going to run the exact same query, and hopefully we get the exact same results that we did when we ran this against Apache Hive Metastore. So two different Metastores, two different sets of data. The tables were created the same way, and they were both built off the same raw data. And we in fact got the same results. So you can see here we have name, nationality, gender. We don't have any null genders. If we have both a birth date and a death date, we can calculate the artist's length of life in years, and that also works. Again, this has demonstrated that we can use superset to run queries using PrestoDB against any number of data sources, including different Hive compatible metastores or Hive metastores. So we ran the first query against Apache Hive, and then we ran the similar query or the same query against AWS Glue data catalog and got the same results back in the query results. In this last part of the demonstration, I'll demonstrate a simple join between two of the tables that we've created in the AWS Glue data catalog. So we'll query the artists for their name and their ID, and we'll query the artwork for the title, the medium, the classification, etc. And we'll combine those together so that we get the artist name associated with each piece of artwork. Again, we're going to be using the AWS Glue data catalog. I'm going to be using Presto, and I'm doing that from within Superset on my Ahana cloud for Presto instance running in my AWS account. So let me grab a simple query that will demonstrate a join. I've already written that. And we'll drop that into Superset. So again, just to walk through this, we're going to be joining the artist and artwork tables, the versions which are in AWS Glue data catalog, the MoMA catalog. We're going to be joining those on the artist ID, so we're using the using statement, which is part of Presto SQL. We're going to be limiting our query to only artists with the nationality of American and the artwork classification of photograph. If you recall from previous parts of the demo, we partitioned the artist data by nationality. We also partitioned the artwork by classification. So we're taking advantage of both of those partitions. We certainly don't have to, but in order to show the efficiency of using the nationality and classifications and narrowing down our SQL statement to those, pushing those predicates down to S3, we'll be able to take advantage of those partitions and only query a minimum amount of data in order to return results. And we'll order that by artist name, by title, and by date. So a fairly simple inner join between those two tables, but it will demonstrate how Presto is able to join two tables in AWS Glue and therefore join two underlying sets of Parquet data in S3 and return those results. So we'll go ahead and run that query. And it took about 4.5 seconds. Superset will limit that to 1,000 rows. We can increase or decrease that depending on what your needs are. But you can see here that we returned only American photographers. We got back the date and the title of their piece in the results. So we returned the artist nationality, the artwork classification, the artist name, the artwork date, and the artwork title. By joining the artist refined table and the artwork refined table, those tables represent underlying data in Amazon S3, which have been partitioned either by nationality or classification and written in a compressed Parquet format, which has been optimized for performing queries on. We did that join, and we see the results in fact work. We were able to join those two tables and get the results back in our results tab.